Okay, so for this one, we're asked to solve this polynomial inequality and state our answer in interval notation. There's a couple of ways to do this. There's probably 3 or 4 ways to do this. I'll show the two that are probably the easiest. First time I'll do this by graphing. If you are good at graphing, then this is the easiest way to do it. If you're not good at graphing, then I'll give you the next option that's a little more plug and chug with numbers, but is still not too bad. So graphing polynomials, if you remember, there's that table that we have positive even, positive odd, negative even, negative odd with the 4 possibilities, and we figure out our zeros and then figure out if it's bouncing and crossing. So that's kind of the basics that go with this. So this would be for our zeros. This is x equals 0. This is x equals 4, and this one is x equals negative 6. So that's the places where we're crossing the x-axis. And then remember, odd powers cross and even powers bounce. So here at the 0, 0, we would expect this graph to go through or to cross at the axis. At 4, because this is an even power, we're expecting it to either come down and bounce or come up and bounce off and turn around, kind of like a parabola. And then at negative 6, this is to the first, again, odd powers cross, so that one's going to be a cross. So then let's just make a really not very good graph, because we don't need a very good graph. We just need to know where it's above and below the axis. So I'm going to call this out here negative 6. I'll have a dot there. And I will use dots on all these because we have this equals. If it didn't have the equals, you might throw an open circle there just to remind yourself not to include the endpoint. That doesn't really matter. Just kind of a way to remember when you're writing down the answer. And then here we have a 4. And so that's our 3 places where this equals 0 is at those intercepts. And the last thing we have to do is figure out if this is positive odd, negative odd, etc. There are, all the x's are positive, so we know it's a positive. And if I count up how many x's I have 1, 2, 3 here, 4, 5, because of the squared, 6. So if I went to the trouble of foiling all this out, my leading term would be x to the 6th, which is positive and even, which means on the grand scheme of things, it should kind of end up looking like a parabola. Important thing is it's going to come in from the top, and it should leave out the top when I do all these bouncing and crossing. So if I come in from the top, I am supposed to cross at negative 6, and then I'm supposed to cross at 0, so pass through that intercept, and then I'm supposed to bounce off of the 4. So I'll have some turning point here, come down and bounce off of the 4. And that's what my graph would look like. Once I have that, let me change colors here. Make it red. We are, in this time, we're looking for greater than or equal to 0. So all the places that this graph is above the axis, that's my solution set. So if I put in negative 7 into this equation, it's some calculations to do, I don't know what it is, but it's going to come out positive because the graph is above the axis, and a positive number is greater than 0. So that means my solution set is going to be right here, including that endpoint. And then right here, so then it's negative for a while here. In this case, I don't have to do anything special with this endpoint because of the equals. If this was just a greater than, I would have to exclude the 4. I would have that as an open circle, and I'd go from 0 to 4, union from 4 to infinity, with parentheses on everything. But since this is an equals, it makes it a little bit easier. Everything from 0 on is either greater than 0 or equal to 0. So that would make my solution set in interval notation from negative infinity up to and including that negative 6. And then we have a gap in there, so we'll do a union. And then from here, we start back up at 0. Again, nothing special about the 4 because it's 0 or positive numbers, so it's just included. So that's going to go out to infinity from there. Just to show what it would have been if it had been, say this was a greater than instead of a greater than equal to, then we'd have negative 6, negative infinity to negative 6, oops, and then parenthesis, union from 0 to 4, and then union from 4 to infinity. So we would just have to exclude that spot there because it would equal 0. So that's kind of the difference between a greater than and greater than equal to. Likewise, if it had been a less than, our only solution would have been here. If it was less than or equal to, we would have had to have included from -6 to 0, and then we would have had to include that single point on the 4. So that's one way to do this. And again, if you're good at graphing, with explaining everything, that went kind of slow, but if you're strong at graphing, you can just look at this and get that graph really quickly. And then you get the visual as to where all the regions are that should work. If you're not super comfortable with graphing, then the alternative is still to make this number line. So figuring out the 0, the 4, and the -6, that's all the same. So we'll come over here and we'll go, this is going to be -6. I'm going to call this 0. And I'm going to call this 4. And then what I can do is use test points. So to do test points, again, let me change colors. I have to test a point on every interval and then see if it comes out positive or negative. If it comes out to a positive number, then that positive number is going to be greater than 0. That would be part of the solution. If it comes out negative, then that means it is not greater than 0, so it won't be part of the solution. So if I were doing this, I would test -7, I would test -1, I would test 1, and I would test 5. And the reason is I'm just grabbing the easiest number I can off of each of these intervals. So let me just show it with one number. I'll test this 1 here just to kind of show what you would do. So this would be 1 cubed, and then 1 minus 4 squared, and 1 plus 6. Oops, 6, there we go. And we're checking to see if that's greater than or equal to 0, and in other words, is it a positive number? So 1 cubed is 1. This would be -3, but squared. -3 times -3 would make a +9, and 1 and 6 would make 7. And so this is 63 is greater than 0. 63 is greater than 0. So that means and I'm including zeros, so from here to here, that's all included. Then I would have to go in and plug in 5 into this. I get 125. 5 minus 4 would be 1. 5 plus 6 would be 11. Those are all positive numbers. So then I would know that that goes to infinity that way. And the 4, again, I know that's a 0 and I'm including it, so that's why I'm not doing anything special there. If I plug in -1, this is a negative, this would be a positive, and that would be a positive, so I would have 1 negative. So I don't know what number that would be, but it would be a negative number, so I would exclude that, whereas this was positive. And if I plug in -7, I'm not going to do it because it's a pain, but if I did, it would come out to a positive number. So if we didn't worry about the numbers and just the signs, that -7 would come out to positive, -1 negative, positive, positive. And so then again, we're getting the same interval I got over here. This isn't hard math. It's a little annoying just because you have to like sit there and grab out a calculator and plug a bunch of stuff in, which bugs me. So I tend to do the graphing. But this is a really safe way to get the answer. The other nice thing about this method is if you run into one that's like, actually let me clear this. And let me just show you one more where that would be useful. Let's say we had x minus 5 over x plus 1 greater than or equal to 0. This is a lot harder to graph the rationals than it is to graph the polynomials. So for this particular one, since the graphing is harder, I might really think about doing test points. So here we have a 0 at 5, and here we have a 0 at -1. Again, this is an equals, and so the 5 is an actual 0, because if x was 5, I'd have 5 minus 5 is 0 divided by 6, and that equals 0. So this point is included. So I'll go ahead and throw a dot on there right now just to remind myself to include that endpoint. But -1 is coming from the denominator, and the denominator is undefined, so that's where we have to make sure that we exclude that point. So I'm just going to go ahead and throw an open dot there to remind myself not to put that in my interval notation at the end. And then for test points, let's pick -2. Oops. Change colors. So we'll pick -2 because it's the smallest, easiest number on that interval. From -1 to 5, I would definitely pick 0 because it's the easiest thing to plug in. And from 5 on, I would pick 6 because it's the smallest, easiest number I could think of to plug in. So if we do that, if I plug in -2, I get -2 minus 5 over -2 plus 1 is greater than or equal to 0, true or false. -7 over -1 is greater than or equal to 0, and that is true because negative over negative would be positive. So that region right there is positive, so we're going to end up including it, which I'll do in a second. If I plug in 0, it's -5 over 1, so that is a -5 or negative. If I plug in 6, I would get 6 minus 5 over 6 plus 1. And you don't really care what the number is. Once you can see that it's a positive number, this one happens to be 1/7, that's a positive number. You care about the positive and negative, not actually the number. So you don't have to really do the calculation, you just have to figure out what the sign's going to be. So now we have greater than or equal to 0, so I want all the positive regions. So I want here, I don't want in there, and I do want over here. And so then when I write my interval notation, this is going to go from -infinity up to -1, and then we would carefully use a parenthesis there because that's that open dot because it's undefined from the denominator. Union that, we do want to include the actual zeros, which is at 5, and so we go from 5 to infinity. So if it's rational, that's where I definitely would do, I would probably do test points, or that's what I tell students to do. There's a third method called sign chart, and I think it's actually easier, but it's harder to learn. So when 2 days before the exam, I would get good at test points, and the test points will work for either